So here what we're going to do is we're going to have a basic look at the idea of stoichiometry. Okay, stoichiometry sounds like kind of a bit of a high-tech word maybe, but it's actually quite simple once you understand what the whole point of it is. Basically, stoichiometry is the analysis of a chemical equation such as this, whereby we look at and we consider the exact number of atoms that react with one another in order to produce, these products. So basically, what we've got here is we know that because of the ratios of the coefficients, here we've got one magnesium hydroxide and two hydrochloric acid molecules. Okay, we know that one magnesium ion and two hydroxide ions need exactly two hydrochloric acid molecules to fully react away. Okay, so for every magnesium ion and every two hydroxide ions, okay, exactly two hydrochloric acid molecules are going to react with them. Okay, similarly, for every two hydrochloric acid molecules that react, exactly one magnesium ion will be produced and exactly two chloride ions will be produced. Okay, because we can break this down as we would in an ionic equation. We can break this down into one magnesium ion and two chloride ions. So for every two hydrochloric acid molecules that react away, one magnesium ion is produced, okay, and two chloride ions are produced. So basically there's a one-to-one correspondence between the number of hydrochloric acid molecules reacting away and the number of chloride ions being produced. Just the same as there is a one-to-one correspondence between the number of hydrochloric acid molecules reacting away and the number of water molecules being produced, okay? And the way we know that is basically through these numbers here, okay? So that's equivalent to having a 1 there. We've got a 2 there, and there might as well be a 1 in here as well, okay? So this is telling us that, one magnesium hydroxide, or in solid form, aka one magnesium ion and two hydroxide ions bonded together in solid form, is going to react with two hydrochloric acid molecules. Okay, so it's these ratios that are important. These ratios tell us exactly how many molecules of one type of thing, or how many particles of one chemical, are going to be needed to react with exactly a certain number of particles of another chemical. Okay, so this is a 1-to-2 ratio between these reactants. Okay, so we're going to need to, if we want to react exactly the right amount of these two, so we don't have anything left over, then what we need twice as much hydrochloric acid as we have magnesium hydroxide. Okay, and when we say twice as much, we mean the number of particles. Okay, so these particles can be molecules or ions or ionic compounds. Okay, but it's all about the number of particles. Okay, not grams. It's not 1 gram is going to react with 2 grams. It's one particle going to react with two molecules here. Okay, so it's a number of particles. Okay, and because we're dealing with number of particles, we know that those numbers get really big when we have, if we look at, a piece of wood. Okay, there's many, many, many billions and trillions of atoms and small particles in there. Okay, so instead of dealing with actually the number of particles, we deal with something that is the same but slightly easier for us to do. So it's equivalent to dealing with mole. Okay, so basically that means we can say that 1 mole of magnesium hydroxide is going to react with 2 mole of hydrochloric acid to produce 1 mole of magnesium chloride and 2 moles of water molecules. Okay, so that's what it comes down to. It's the ratio between the number of moles of reactants and products. Okay, so what we're going to do here is we're going to do a little bit of an example just to really understand how we use and apply this idea. Okay, so I've got 3 grams of solid magnesium hydroxide, and we want to know how many milliliters of 1 molar hydrochloric acid is needed to completely react with the 3 grams of magnesium hydroxide. Okay, so we need an exact amount of hydrochloric acid that's needed to react with 3 grams of magnesium hydroxide. Okay, so first we know that we're dealing with the number of particles. Okay, and therefore we're dealing with the number of mole. Okay, so what we're going to do first is we're going to find the number of mole of magnesium hydroxide. Okay, the first step to doing that is finding the molar mass of magnesium hydroxide. Okay, so mm of magnesium hydroxide is equal to, now we add up the molar masses of each of the particles in there. So magnesium has a molar mass of 24.3. These are all, remember, the atomic masses listed on your periodic table. They are the same as the molar mass. Okay, so magnesium is 24.3. We've got 2 oxygen at 16 each. Two hydrogens. Okay, and we add those all together. we get 58.3. Okay, so now we've got the molar mass of magnesium hydroxide. Now we want to know the number of mole we have. Okay, so we know the mole of magnesium hydroxide is equal to the mass of magnesium hydroxide over the molar mass. Okay, so we're really thorough here by filling in, what the substance that we're talking about in brackets every time. Okay, and stoichiometry is when this idea becomes really important. When this whole idea of really thoroughly, identifying what you're dealing with each time, because we're dealing with a few different substances, so it's really important here to deal with it like that. Okay, so we know we've got 3 grams. The mass is 3 grams. The molar mass is 58.3. Okay, and this comes out to 0.051 mole. Okay, so next what we do is we move over to the next part of the question. Okay, so what we want is the number of mils of 1 mole of acid that is needed to completely react with this 3 grams, okay, to completely react with the 0.051 mole. Okay, so what we do then is we know that by ratios here, we've got 1 mole of magnesium hydroxide reacting with 2 mole of hydrochloric acid. Okay, so we know that the mole of hydrochloric acid is going to be 2 times the mole of magnesium hydroxide. Okay, we've obtained that knowledge from the equation and the ratios of the coefficients. So it's going to be 2 times 0.051 or 0.103 mole. Okay, so now we know that we need 0.103 mole of hydrochloric acid. Okay, and now we need to figure out what that means in terms of how many milliliters of 1 molar hydrochloric acid do we need to completely react. Okay, so we know up here we remember our equation C equals N over V. Okay, we rearrange that. This time we're trying to find the volume, so we rearrange that to give V equals N over C. Okay, we know that N is equal to 0.103. Okay, and the concentration is equal to 1.0. So it comes out that this is the volume is 0.103 liters. Okay, and this is where you look back to the question, you ask exactly what the question was asking. It asks for milliliters. So what we write out is 103 milliliters. Okay, so that's kind of how we deal with. It's kind of a pretty generic, stock standard sort of stoichiometry question. We're given an equation, and we figure out exactly how many moles are needed on either side with the reactants. Okay, how many moles of each reactant are needed. Okay, then we can calculate, how many moles of one reactant we need, given we have a certain number of moles of the other reactant. Okay, and so our final answer is 103 milliliters.